Hi everyone, in this video we're going to learn how to do linear regression in Google Sheets. The more collaborative nature of Google Sheets makes it easier for you to use it in your projects. So just to explain you, a linear regression is nothing but a model which estimates the linear relationship between an independent variable and a dependent variable. These independent variables are also called as explanatory variables. So whenever there is only one explanatory variable, it is called as simple linear regression. And in this video, we're going to learn how to do linear regression through Excel using only one explanatory variable. So the idea of linear regression is essentially to convert this sort of data into an equation, a linear equation. So right now, it should be y is equal to a plus bx. My main motive is to basically use the data I have here, the height and weight of students of a particular class, to make this sort of equation. So whenever a student comes to me that hey, my height is this or my weight is this, I can actually predict my um, dependent variable. So there are two different methods in which you can actually do this particular analysis. The number one method is a simpler method, and that is using graphs. So I'm going to go ahead and select the data. I'm going to insert. I'm going to insert a chart. So the idea here is to essentially use a scatter plot. So you see here in the chart editor, I have the data range set up, but you always have to have this as a scatter chart. You're going to go to customize. Now remember, our motive is to generate a linear equation. And if you remember, a linear equation always has a line associated with it. So what we're going to do is we're going to go ahead and edit the series, right? And what we're going to do is we're going to click on trend line. So the very first thing we've done here is we have added a trend line that would be the line that you generate when you basically generate the equation. Then you're gonna scroll down a little bit in the customize section only, and you're gonna use equation here. So if you see here, you actually would get the equation as well. So now that you've gotten the equation, you can basically predict the weight when you have the height given. So here the weight is the dependent variable and the height is the explanatory variable, right? And then you're gonna also click on r square here. So r square is nothing but a coefficient of determination, which essentially gives you the variation of the um, model that you have done. So here, but like this is so I'll just go ahead and do another analysis, which actually is a more detailed one. But right now, you've generated this sort of a equation. So x is your height, and you can basically generate weight as well. So the next option of doing it, and you can remove r square whenever required. The next option of doing it is using a function, and that function is called as the line list function, right? So what I'm going to do is I'm just going to move this chart to the right hand side so I have space for this. I'm going to type line list, right? Now it's basically asking you in the function to pull in or put in the known data y. Always remember y is always the dependent variable in linear regression. There can only be one y. There can be multiple x's depending on what your problem statement is. So I'm gonna go ahead and select the y. And now I'm going to select the x. It's important to note that if you have more than one independent variable, you can select the whole data range, right? and then I'm gonna write true for both of them. I'm gonna enter. Now, if you see, this doesn't really make a lot of sense, but what we're gonna do is we're gonna go ahead and just write slope and intercept. If your motive is to just generate an equation, the first method is the best for you. But if your project asks you to check all um, you know, um, the assumptions that you do take for linear regression, it's very important for you to basically use this function to determine everything, right? So let's basically look at all these numbers and then we can move ahead with our analysis. All right. Firstly, we have, okay, so now what I've done is I've actually added all the help text for you to understand what this is all about. So whenever you use the linus function, please for the first column write slope and for the second column write intercept. And then add coefficient, standard error, r square, f value, and residual sum of squares. So the idea here, if you see for the coefficient, is essentially to determine what the equation would be. So let's just actually go ahead and determine what the equation would be for this particular um, problem, right? So now recall that our dependent variable is weight, and our coefficient for the intercept is what? It is nothing but 137.416. So I'm just going to write 137.416. It is this particular value. Okay. And then we're going to write slope for the dependent variable. So we have only one in, independent variable, and that is our height. So what we're going to do is we're going to write, so since it's minus here, we're just going to write minus, right? We're going to write minus and then we're going to write 0.35, and I'm just going to write height. So I've just taken it to be 2 3 decimal points. You can of course go ahead and change them and change the whole method, but I like it this way, right? So this is the equation, and recall in this particular value as well, this is exactly what the first particular method gave us, right? Let's now interpret a couple of things here, right? The number one thing is r square. So if you look at this particular value in the third row, r square is 0.044. This is the coefficient of determination as I mentioned before. And in this example, it's not a very good example, but what we can determine is 4% of the variation in the weight is basically explained by the height. I hope that's clear. Moving on to the standard error. So the standard error here is 8.257. So essentially the observed value, so whenever you actually enter something in the height option, the observed values of weight basically would be an average of 8.25 units away from this, right? From the regression line. So if you see here, you have a linear line, but you see a lot of points away from this regression line, right? And that is essentially explained. This particular number is explanatory of that. So that is the explanation of the standard error. So this is what basically all the information you can get in your um, Google Sheets to do linear regression. I hope this tutorial was helpful for you. Thank you and please subscribe.